Hello students, I'm going to solve 40 questions from each and every chapter for CBSE 10th class mathematics. So I have selected 40 questions from each and every chapter. Let us try to solve these 40 questions now. So here's the first question. The decimal form of 129 by 2 power 2 into 5 power 7 into 7 power 5 is. So this is not of the form 2 power m into 5 power n. If the denominator is of the form 2 power m into 5 power n, then we'll be getting a terminating decimal or else non-terminating repeating decimal. Since we have extra here 7 power 5, this is non-terminating, non-repeating decimal. So the answer is option C. Second question. HCF of 8, 9 and 25. So first pick up two numbers 8, 9. The HCF of these two numbers is 1 and HCF of 1, 25 is 1 again. So the option is answer D. Third question. Which of the following is not rational? Which of the following is not irrational? So if you look at the option B, it contains 2 minus root 3 by 2. Here root 3 is the rational number. Even option 2 contains root 2 plus root 3, which are irrational numbers. If you look at the option C gives you root 2 minus root 3 into root 2 plus root 3, which is of the form a minus b into a plus b. If you solve this, you will get a square minus b square, that equals to root 2 whole square minus root 3 whole square, which gives you minus 1. So minus 1 is not a rational number, it's a rational number. So the answer is option C. Fourth question. The product of a rational and irrational number is. Let us take an example of rational and irrational numbers. So when you multiply rational and irrational numbers, 2 into root 3. Here 2 is a rational number, but whereas root 3 is a irrational number. 2 into 1.732 and it keeps on going. Irrational number is a non-terminating, non-recurring decimal. If you multiply 2 for this, again you are going to get the same kind of number here. So we'll be getting a rational number again. So the product of a rational and irrational number is rational number. We'll go to fifth question. The sum of rational and irrational number is. Again the same goes with this. Sum of rational and irrational numbers. 2 plus root 3. When you add these two, 2 plus 1.732 and it just keeps on going. You will get 2.732, which is again an irrational number. So no matter what, if you multiply rational and irrational numbers, if you add them or subtract them, you're going to get the irrational numbers. Now come to sixth question. The product of two different irrational numbers is always. Even if you multiply two irrational numbers like root 2 into root 3, you're going to get again an irrational number. So root 2 is 1.414 and it just keeps on going, never ending, into root 3 is 1.732. when you multiply never-ending decimals with each other, you're going to get something which is a rational number. Irrational numbers are something like nonsensical numbers. They make no sense in mathematics. So the option is B, irrational numbers. Coming to 7th question. The sum of two irrational numbers is always. Again the same question, it's irrational number. 8th question. If b equals to 3, then any integer can be expressed as a. If you apply Euclid's algorithm, division algorithm, we can write any number as p equals to b into q plus r, where r is ranging from r is more than or equals to 0 and less than b. So b equals to 3, then any integer can be expressed as, you can express any integer in the form of either 3q, 3q plus 1 or 3q plus 2. You can just check this out. If q equals to 0, you will get 1. If q equals 0, you will get 0, 1 and 2. And here if q equals to 1, you will get 3, 4, 5. And if q equals to 2, 6, 7, 8, this keeps on going. So any integer can be expressed as 3q, 3q plus 1 and 3q plus 2. Next, 9th question. The product of 3 consecutive positive integers is divisible by. The product of 3 consecutive positive integers is divisible by. So since it's an MCQ, you can just take an example of 3 positive integers. Let us take 3, 4 and 5. So these 3 are the consecutive positive integers. If you multiply this, it's 60. So from the options, 4 is a factor of 60 and 6 is a factor of 60. Let us take 3 more numbers. Let us say 6, 7, 8. Now 6 into 8 is 48. 48 into 7. 48 into 7 is divisible by 6 but not. So even this is divisible by 4. If I take 1, 2, 3, the first 3 natural numbers, the product is 6, which is not divisible by 4. The option is B. Next, coming to 10th question. The set A equals to, so given from 0, 1, 2, 3 and so on up to infinity. So this set represents the set of whole numbers. The option A. Next, 11th question. Which number is divisible by 11? So the condition for divisibility test of 11 is that, let us take the first option, which is 1516. The divisibility test condition for 11 is that the sum of the digits of the alternative places should be divisible by 11. So if you take alternative places here, the sum is 1 plus 1, 2, and if you subtract from the 5 plus 6, which is 11, it will give you minus 9. So minus 9 here is not divisible by 11. So option 1 is not the correct answer. If you go to option B, Option B gives us 1452. The sum of these two alternative digits equals to 6 minus sum of these two is again 6, which gives you 0, and 0 is divisible by 11. So option B is the answer. If you want, you can just cross check the answer. 1452 by 11. So it is 11 one time is 11, and the remainder is 335. 11 three times is 33, and then 11 two times is 22. So it is exactly divisible by 11. If you go to question 12, LCM of the given number x and y, where y is a multiple of x is given by. Whenever you take two numbers x and y, and out of these two, if one number is the multiple of another number, then that number will become our LCM. So here y is a multiple of x, so y will be our LCM. It is like if you take 4 and 24. 24 is a multiple of 4. So whenever you find the LCM of 4 and 24, you'll get 24 as the answer. Moving on to 13th question. The largest number that will divide, so it's given as 3,98,436 and 542, leaving remainder 7, I'm sorry, this is 398, 436 and 542, leaving remainder 7, 11 and 15 respectively is. So here is asking about the HCF, is asking about the largest number. The largest number is nothing but HCF of these three. But we need to find HCF of these three. When you divide the number 398, you must get the remainder as 7. So when you divide 398, you must get the remainder. If I subtract the remainder, I'll get 391 here. And do the same thing for the remaining numbers. Given 436. If I divide the number 436, I should get the remainder as 11. So if I subtract these remainders, I'm going to get the dividend, which is exactly divisible. So 436 minus 11 is 425. And the third number is 542. 542 minus 15, which is equals to 527. Now we need to find the HCF of these three numbers. So if you find the HCF of these three numbers, you'll get the answer as 17. You can just check this out if you want. So 425 divide with 391. So this is 391, 1 times is 391. This is 4, and this is 12 minus 9 is 34. Since the remainder is not 0, again divide 391 with 34. This is 34, 1 times is 34. And the remainder is 51. I'm sorry, this is 34 into 34, 1 times is 34. You get 51. So if you divide 34 1 times again, 34 and 51, this gives you 17 here, and divide 34, 17. So 17 into 2 times is 34. The remainder is 0. And even if you solve for the other two numbers, you get 17 as the HCF. So next, moving on to 14th question. So here is a word problem. There are 312, 260 and 156 students in class 10, 11 and 12 respectively. Buses are to be hired to take the students to a picnic. Find the maximum number of students who can sit in a bus if each bus takes equal number of students. So here we need to find the maximum number of students who can sit in a bus if each bus can take equal number of students. Given the number of students in class 10, 11 and 12 are 312, 260 and 156. So remember that here we need to find the HCF. HCF denotes highest common factor. So it is highest common factor. Whenever we have the word problems, if it gives terms like maximum, tallest, largest, more or most, so whenever it's the biggest, whenever we have keywords like these, we need to find the HCF because it's the highest one. So whatever the terms we have synonym with highest, the tallest, largest, biggest, we need to find the HCF. It's like a tip for you to remember what to find, whether to find the HCF or the LCM. So in our question, we need to find the HCF. First, let us try to find the HCF of 260 and 312. So dividing 312 with 260, this is 260 into 1 times is 260, and the remainder is 40 plus 12 is 52. So divide 260 again. 52 into 5 times will give you 260. The remainder is 0. So for the numbers 312 and 260, we got the number 52 as the HCF. Let us find the HCF of 156 and 52. So I'll erase this to get the space. (52) and 156. So this is 52 into 3 times will directly give me 156, and the remainder is 0. So 156 equals to 52 into 3 plus the remainder is 0. 52 is our HCF. So 52 students can be allocated in one bus. So this is the maximum number the students can be accommodated in one bus. Moving on to next question, which is 15th one. There is a circular path around a sports field. There is a circular path around a sports field. There is a circular path around a sports field. There is a circular path around a sports field. There is a circular path around a sports field. There is a circular path around a sports field. There is a circular path around a sports field. There is a circular path around a sports field. There is a circular path around a sports field. There is a circular path around a sports field. There is a circular path around a sports field. There is a circular path around a sports field. There is a circular path around a sports field. There is a circular path around a sports field. There is a circular path around a sports field. There is a circular path around a sports field. There is a circular path around a sports field. There is a circular path around a sports field. There is a circular path around a sports field. There is a circular path around a sports field. There is a circular path around a sports field. There is a circu Priya takes 18 minutes to drive one round of the field. Harish takes 12 minutes. Suppose they both start at the same point and at the same time and go in the same direction. After how many minutes will they meet? So here let's try to understand the question first. There is a circular path around which Priya is revolving. So Priya is revolving here. Let's say Priya is revolving like this. So Priya takes 18 minutes. Harish takes 12 minutes. And there's one more color here. So Priya and Harish are moving now. Since they're starting at the same point, now Priya in 18 minutes she will complete one round. By the time she completes one round from here to here, Harish takes 12 minutes, so he will be lagging behind Priya. So he will be somewhere here in 12 minutes. Suppose they both start at the same point and at the same time and go in the same direction. After how many minutes will they meet? So here we need to find the LCM. LCM gives the answer for us. The LCM of 18 and 12 gives our solution. They will be meeting at the same point when they make the least common multiple possible. LCM of 12, 18. So if you find the LCM of 12, 18, divide with 2 and 3 here. The LCM is 36. After 36 minutes, Priya and Harish will meet at the same starting point. Next is 16th question. Express 98 as the product of its primes. We need to do the prime factorization here. Take the number 98. Since it is an even number, divide with 2. 2 4 times is 8. 2 9 times is 18. Next we have 49. 49 is not an even number, so it is not divisible by 2. Move on to next number 3. Even 3 is not a factor of 49. Next 5 is not a factor. Then go to the next prime number, which is 7. 7 into 49 is equals to 2 power 1 into 7 power 2. Option C. The next question is 17th one. 3 farmers have 490 kg, 588 kg and 882 kg of wheat respectively. Find the maximum capacity of a bag so that the wheat can be packed in exact number of bags. In the question, the keyword is the maximum again. As I told you, whenever you find the larger terms, the bigger terms, we need to find the HCF. So find the HCF of these 3 numbers. Dividing 588 with 490. 490 is close to 588. 490 1 times is 490. The remainder is 8 here and 9 here. Dividing 490. 98 into 5 times will give you 490. So the remainder is 0. 98 is the HCF of first 2 numbers. Dividing the next number 882. with 98. So 98 into, go for 8 times, because 98 into 10 is 980, 8 times, 8 8 is 64, 6 carry, 784. So 98 into 8 times will give you 784. The remainder will be 8. This is 7. This is 98. So dividing 98 with 98, 1 times is 98. So 98 is the HCF. 98 is the solution. Next question is 18th one. For some integer p, every even integer is of the form. The general form of an integer is 2 into n. So n is some integer, n belongs to an integer here. The option is 2 times of p. For some integer p, every odd integer is of the form. The general form of the even odd number says that 2 into n plus 1. So for every even number, if you add 1, you'll get the odd number. This is our general form of the odd number. Option A is the answer. Moving on to 20th question. M square minus 1 is divisible by 8 if m is given. M square minus 1 is the expression, and it is divisible by 8 if m is Moving on to the options, we have an even integer, an odd integer, a natural number, a whole number. If you put some even integer like 10, we will get 10 square minus 1, which gives us 99. 99 is not divisible by 8. If I go to the next odd number 11, I will get 11 square minus 1, which is 121, minus 1, 120. 120 is a multiple of 8. Whenever we put the odd integer, 8 is the factor of the result. So an odd integer. You can just check with other integers if you want. If you put 9 in the place of m, you'll get 9 square minus 1, which is 81 minus 1 equals to 80. So 80 is the multiple of 8. So option is B. Next, 21st question. If two positive integers a and b can be expressed as a equals to x into y cube and b equals to x power 4 into y into z, x comma y being prime numbers, the LCM of a comma b is. So the LCM is we have x into y cube and x power 4 into y into z. To find the HCF, take common of these two expressions, which is x into y. X into y is the common part in these two expressions. Whereas to find the LCM, we need to unite these two expressions and don't repeat the common part. So LCM will be x power 4. X is a part of x power 4 into y cube. I'm writing y cube because y is a part of y cube into z. This is our LCM. So it is x power 4 into y cube into z. Option 4. Next, 22. The product of a non-zero rational and an irrational number is. So it's a product of rational and irrational numbers. You've gone through this question already. It's always irrational number. Next, 23rd. If two positive integers a and b can be expressed as, this is the same question again, it's x into y cube and b equals to x power 4 into y square into z. X comma y being prime numbers, HCF. We solved it in the previous questions. The HCF is x into y here. I'm sorry, it's y square here, so HCF will be y square, x into y square. So option A. Next, 24th question. The largest number which divides 60 and 75, leaving remainders 8 and 10 respectively is. The largest number which divides 60 and 75, leaving remainders 8 and 10 respectively is. When you divide the number 60, you must get the remainder as 10. If you subtract this, it should be the exact multiple, which is 52. And similarly, if you divide 75, the remainder is 10. Subtract the remainder, you get 65. So these two are the numbers. Now we need to find the largest number which divides these two numbers. In the sense, we need to find the HCF, the largest number which divides the common factor, right? The highest common factor, largest common factor, or the greatest common factor. The greatest common factor of 52 and 65, these two comes in 13 table. So 13 is the greatest common factor. Option D. The least number that is divisible by all the numbers from 1 to 5, both inclusive, is. If you observe the technical terms, here is the least number. The least is the least common multiple, lowest common multiple, which is the LCM. LCM of 1, 2, 3 and 4 and 5. LCM of 1 to 5. Product of these two is 15, and the LCM of 2 and 4 is 4, which gives you 60. 60 is the LCM. 60 is the first number which is divisible by 1, 2, 3, 4 and 5. Next, 26th question. The least number that is divisible by all the numbers from 1 to 8. Now we need to find from 1 to 8. So till 5 we have already did 60, the LCM. And next 6, 7, 8. Or I can do directly. 2, 4 and 8. If you observe, 8 is the LCM out of 2, 4 and 8. So 8, comma. In 3 and 6, 6 is the LCM, and 5 and 7 are prime numbers. So write as usual. The LCM of 8 and 6 will be 24. 24 into 5 into 7. That equals to 24 into 35. So 35 into 24 is 840. Option A. Next question is 27. The decimal expansion of the rational number will terminate after. So this is a fraction, given fraction. This will terminate after 1 decimal place, 2 decimal, 3 and 4 decimal places. Write the denominator as 25 into 10. So I'm trying to write this in the form of 2 power m into 5 power m, which is, this is 5 square into 5 into 2. For these to apply law of exponents, a power m into a power n, it is 5 cube into 2 power 1. The given decimal will be terminating after the highest of these two numbers, so after 3 decimal places. 28. The decimal expansion of the rational number will terminate after, so 97 by 2 into 5 power 4, so 4 is directly 4 places. The product of 2 consecutive natural numbers is always. The product of 2 consecutive natural numbers. Take an example. 2 consecutive natural numbers, 3 and 4, the product is 12. Let us take 7 and 8, this is 56. If you want one more example, let us say 11 and 12, which gives you 132. So the options are given as prime number, even number, odd number, even or odd. So whatever the examples we take, we're always getting the even numbers. So option B. Thirtieth question. If the HCF of 408 and 1032 is expressible in the form of 1032 into 2 plus 408 into P, then the value of P is. So the HCF of the two numbers is expressible as this format. Let's find the HCF of 408 and 1032. .408 and 1032, right? So if you solve this, you'll get the HCF as 24. I'm doing this directly. So the HCF equals to 24, and this 24 is expressed as 1032 into 2 plus 408p. .24 equals to, this is 2064 plus 408p. So 408p equals to minus 2040. P will be equals to minus 2040 by 408. So this will be equals to 408 5 times, 8 5 times is 40, 5 4 times is 20, so it's minus 5. The value of P equals to minus 5. Option B. Moving on to next question, 31. The number in the form of 4p plus 3 where p is a whole number will always be. Given number is 4p plus 3, p is a whole number. If you put p equals to 0, you will get 3. If p equals to 1, this is 7. And if p equals to 2, you will get 11. So these are always odd numbers. Even if you put p equals to 10, we will get 43, which is again odd number. So option is B. Second question, when a number is divided by 7, its remainder is always. So the remainder will be always lying between more than or equals to 0 and less than 7. This is the condition from the Euclid's division algorithm. So it's less than 7. Option C. Third one. 6 plus 5 root 3 minus of 4 minus 3 root 3 is. If you solve this, 6 plus 5 root 3 minus 4 plus 3 root 3. So this gives you 2 plus 8 root 3. Root 3 is a rational number. When you multiply root 3 with a rational number, you'll get a rational number. And if you add this to 2, overall you'll be getting again a rational number. So option is B. Next, 34th question. If HCF of 16, y equals to 8 and LCM of 16, y equals to 48, then the value of y is. We have the formula that HCF into LCM of two given numbers will be equals to product of the numbers. So the numbers are here 16 and y. HCF is given as 8 and the LCM is given as 48. In solving this, y equals to 8 into 3, 24. Option A. 35th one. According to the fundamental theorem of arithmetic, if t is a prime number divides, this is b square, but b is more than 0, then. So when we prove the condition of the irrational numbers, when we have the questions like prove that root 2 is irrational, we get a condition where if a square is divisible by p, then a will be divisible by p. So here it's t is a prime number if it divides b square, and t also divides b, so t divides b. So option A. Next is 36th one. The number pi is. So pi equals to 22 by 7. But this is just an approximation actually. It's not the exact value. The value of pi is equals to 3.14 and it goes on to never ending. It goes to billion trillion digits. So it's some kind of nonsensical number. It doesn't make any sense for us. So it's an irrational number. Option C. Next is 37. If LCM of two numbers equals to 693 and HCF of two numbers is, so apply the formula LCM into HCF equals to product of the two numbers. So 693 is the LCM into, we need to find the HCF equals to, the two numbers are 77 and 99. So HCF equals to 77, 99. So try with 11. 11 9 times. 11 6 times is 66. 11 3 times. 7 9 times. 7 11 times. 9 gets cancelled. So 11. Option A. Next is 38th one. Euclid's division lemma states that for two positive integers a and b, there exist unique integer q and r such that a equals to bq plus r, where r must satisfy. So whenever it comes to Euclid's divisional lemma, it's more or less like the remainder theorem, where if you take a number, let's say 9, if you divide this with 2, you get the remainder as 1. You can write this 9 as 2 into 4 plus 1. This remainder will be always lying between 0 and the divisor. So the remainder will be more than or equals to 0. If here the number is 8, the remainder will be 0. So it can be equals to, remainder should be more than or equals to 0, or it will lie between b. This is our condition. So option D. So last two questions. 39th one. For positive integer a and 3, there exist unique integers q and r such that a equals to 3q plus r, where r must satisfy. So r must satisfy r more than or equals to 0 and less than 3. So here it's like one option is Q and wrong, option C. So this is your answer. If you have r more than or equals to 0, option A will be the answer. So go to the last question now, 40th one. Find the greatest number of 5 digits that will give us remainder of 5 and divided by 8 and 9 respectively. So we need to find the greatest number of 5 digits that will give us remainder of 5. We have that keyword as greatest, but don't confuse here, it's not the HCF. Here we need to find the LCM. But we need to find the greatest number of 5 digits. For 8 and 9, the LCM is 72. When divided with 8 and 9, you must get the remainder as 5 now. 72 into some number x if you divide the number x with 72 for some quotient, you must get the remainder as 5. If you subtract this minus 5, let me erase this first. The greatest number, first the number of 5 digits is that 1, 0, 0, 0, 0. So it's 10,000. $10,000 is my first 5-digit number, and the last will be all 9s. 9999. This is the last 5-digit number. So it takes a lot of time. Let's check the options or else. If you divide with 8 and 9, so dividing the first option 99921 by 8. This is 8, 1 times is 8, 19, 8 2 times is 16, 39, 8 4 times is 32, 72, 8, 9 times is 72, 0. The remainder is getting 1, so now the first option. Going back to second one, this is, the only change is that we have 3, 1 here. So 8, 9 times is 72, we're getting 11, so option B. And going to option C, we have 41 next, 21 is a remainder. So 8 2 times is 16, so when 8 2 times is 16, 5 is a remainder. So option C is getting satisfied with 8. Also check for 9. So it is 999, 4 1 by 9. So 9 1 1 1 1 0. 9 4 times is 36. The remainder is 5. So option C is satisfying. So that's all about the 40 questions from the first chapter, real numbers. We will discuss the 40 questions from the other chapters even. So subscribe to my channel and just watch the videos. Thank you guys. Bye bye.